Hello student, I am welcoming all of you on this Drishti online platform for the fifth episode of the 100 most important topic for Prelims 2026 of Geography. And in this fifth episode, I am going to discuss first of all that the fourth episode some questions are there, so we'll have to solve those answers, and several students must be waiting for those answers. So let us see the answers and that is this topic I have covered in the fourth episode, and let us see the questions which we have seen in the fourth episode. There is with reference to cirque, consider the following statements. Cirques are typically found in volcanic regions. No, it is found in the glacial regions. Cirques are found in what we can say, it is found in glacial regions. So this is a wrong one. A cirque is a bowl-shaped depression formed at the head of the glacier. Yes, bowl shape, semicircular shape, and this is in a bowl-shaped depression. This is more important to understand. It is at the head of the glacier. This statement is correct. And here it is formed mainly due to glacial erosion processes like plucking and abrasion. It is formed mainly, again I said, that due to glacial erosion processes. So glacial erosion processes like plucking and abrasion. These are two important, I said, that forces related to the glacier landforms. So these are the two erosional forces which is responsible for the formation of glacier erosional process. So we can say that two statements, we can say that correct. 2 and 3. First is wrong, and then we can say that option B is correct. So, and here we have to see in the third, this question, with reference to the esker, consider the following statements. Eskers are long, winding ridges composed mainly of sand and gravel. Yes, it is made of sand and gravel, long and winding or sinuous. This is an what correct one. They are formed by deposition of sediments by subglacial meltwaters. Yes, sir, they are formed below the glacier. There is a subglacial region in this melting and giving, I said, that those sand and gravels, and they are forming what ridges like feature, and you can say that these are the ridges like feature. It is an esker. And please go and see the last videos so that you can be able to understand it very well, these questions. And the next one is this statement, it is by the subglacial meltwaters. This statement is correct again. They are formed by deposition of sediments, especially sand and gravel, by subglacial meltwaters. Eskers are typically found in desert regions. No, it is a wrong statement. So only you can say that 1 and 2 is what correct. So this way we have been able to see this question. And then now the next one we have to see related to the moraines. And then with reference to moraine, consider the following statement. Moraines are accumulation of unconsolidated glacial debris such as rocks, sand and clay, such as rocks and sand. And the moraine, it is in the last videos we have seen that in the fourth episode we have seen about it, as I say, that there is a lateral moraine, medial moraine, terminal moraine. So there are different moraines are there, and they are out, I said, that debris of rocks, there is sand and clay. Moraines are, this statement is correct one. Moraines are exclusively formed by wind action in cold desert. No, it is made by the deposition of what I can say that deposition of debris of rocks, sand and clay in glacial regions, not in the desert. They are formed due to deposition by glaciers. Yes, it is a depositional feature of the glacier. It is a, so this statement is also correct. So we have been able to see in this, it is in a C, 1 and 3 are correct. And next one, this is a, we are going to see glacial lake outburst flood. And here that glacial lake outburst flood related question here. With reference to glacial lake outburst flood, consider the following statement. Yes, this is what glacial lake outburst floods, short में हम लोग what we say it as GLOF. So here it occurs due to sudden breach of glacial lake dam. It occurs due to sudden breach of glacial lake dam made of ice or moraine. Yes, this statement is completely correct. Please, if you are not able to understand, go back and see in the fourth episode of this I said that 100 most important topics of geography for the prelims 2026. Go and see, and you'll love it. Yes. And another second statement I can say, it can be triggered by earthquakes. Can be triggered by earthquakes. And yes, the lakes are there. It can trigger, and then possibly it can put the pressure on the dam. The glacial lake outburst flood can happen. Avalanche, it can be rapid melting of glacier. Yes, all the three. You can say that it is a correct one, and we can be able to see like second statement is also correct. It is in a slow onset of disaster. No, it is a rapid. Suddenly it happens. So it is not a slow onset of disaster. So it is a wrong one. It is okay. So we can say that option A, 1 and 2 only is what? Correct, related to this one. And here we have to see expanding Himalayan glacial lakes. Related to that, we have to see that with reference to expanding glacial lakes in Himalayas, consider the following statement. So what we have to see, that expansion of glacial lakes is primarily driven by rising temperature. So rising temperature and glacier retreat, yes, the glacial lakes are, I said, the rising temperature means climate change or global warming, and the glacier retreats. So the glacier retreat, that the lakes sizes keep on increasing. Melt water, it is giving large amount of water. So most next one, this is the correct one. Another, most expanding glacial lakes in the Himalayas are dammed by unstable moraines. Yes, most of the glacier lakes which are formed, and ahead of it there is moraines are there. They have dammed it and created a lake. So the most of them, it is made by this unstable moraines. So it is also correct one. So remote sensing and satellite imagery are used to monitor glacier lake expansion. Yes, remote sensing, what you can say, geographical information system, and whatever we are getting, accordingly we are try to see that whether it is expanding or how much it is there vulnerable, and accordingly some engineering, and we try to make it control and make it stronger. So this way we can say that all the three are correct. Here the option D we can be able to say. And now in the fifth episode we are going to cover that these are the important topics for the prelims 2026: Continental Shelf, Abyssal Plain, Oceanic Trench, Atlantic Meridional Overturning Circulation, and then we have to see climate impact of warm ocean current and climate impact of cold ocean currents. So these are the topics we have to cover. And first of all, I say that if I have to cover this one, so let us see about it. Here in the coastal area, if we can say that this is your continental shelf, thereafter continental shelf is there, and thereafter continental slope is there, and thereafter there is a continental rise is there, and thereafter it is in a deep sea plain, and here in the middle of it there is a mid oceanic ridge is there. So this is your mid oceanic ridge. This is what you can say like it is in a abyssal plain. It is an abyssal plain, and this one is you can say that continental rise. And here we have to see like this one is in a continental slope, and here you can say that this is your continental shelf. So here we are watching, these are the from this and its average depth of continental shelf is 200 meter, or you can say that around 100 fathom. So it is in a 200 meter, or around you can say 100 fathom. So and continental shelf, and thereafter there is a continental slope is coming. Which one I said that? Continental slope. And after that suddenly there is a break of continental shelf. From here suddenly you can say that slope is increasing. It is known as till 200 to 2000 meter around. You can say that 200 to 2000 meter around continental slope, and after the slope again started rising, so it is known as what 2000 to 3000 meter, it is what you can say, that is in a continental rise. And after that abyssal plain is there. Abyssal plain means it is also known as a deep sea plain, and it can be somewhere somewhere it is at the depth of 3000 meters, somewhere it is at the depth of 4000 meters, somewhere at the depth of 5, somewhere 6000. So it is found at the depth of what 3000 to what 6000 meter. So it is in a deep sea plain, and it has a lots of what I said, that uneven feature is there. But since long, lots of in the ocean, you can say that in the ocean lots of meteors, some kind of animals which are dying, their deposition is over there. Because of the deposition, this abyssal plain looks flat. And in this region, several polymetallic nodules like phosphoric polymetallic nodules, like iron, manganese, different polymetallic nodules means in the water. Suppose you have seen sometimes if you have seen, like I say, like in the water some chemicals are dissolved, and it is looking like a liquid, nothing looking like there is any sediments are there. It is a completely liquid, watery. But when you are adding something into some chemicals, suddenly some dissolved solution precipitate out, and it become on the bottom it precipitate forms, and that is way we are knowing it is known as hydrogenous, means from the water dissolved solution. Suppose I have dissolved the sugar in the water. If I have dissolved the sugar in the water, what will happen? Then water will look, like I said, that transparent. Now the sugar has been dissolved, but through some chemical process we can precipitate out those sugar and seat it at the bottom. That is known as precipitation out. It is in a hydrogenous deposits. So through the pressure chemical changes, some hydrogenous deposit is taking place. It is known as nodules. Like a nodule means potato size, that polymetallic, different metals form. There is a polymetallic nodules you can find in this. Here you can be able to see several polymetallic nodules, and then these are of phosphorus. It can be of what iron, it can be of manganese, or different, it can be cobalt. Yes, different kind of it. This abyssal plain lies between continental rise to the mid-oceanic rise. It lies between this, and in this region, continental shelf, if I am talking about in the continental shelf, you know that this is your 200 meter depth. In this region, what is happening? This is your continental shelf. In the continental shelf, it is very much important that that the depth is what the average depth. It is in a depth, especially it is in an average, it is around 200 meter. So in this region, a good amount of photosynthesis take place, and due to the photosynthesis, sun rays are coming, and then there is photosynthesis, and photosynthesis is taking place in the continental shelf. Again, I am talking about continental shelf. And photosynthesis, who is doing photosynthesis is a phytoplankton. So phytoplankton is the water absorb carbon dioxide, and make food. So it is the producer of the ocean. So phytoplankton is the producer of the ocean, you can say. And these phytoplanktons are eaten by, I said that in the zooplanktons, it is eaten by zooplanktons, and these are very small, very tiny, very small zooplankton, and they are eaten by small fishes. They are eaten by what? This zooplankton and phytoplanktons are eaten by small fishes, and then further medium size fishes, and there's a large fishes, and other marine animals. In the short, I am trying to say there is a large. So in the continental shelf, large fisheries ground. Here will be a, you can say there will be a large fisheries ground can be there. Yes, a good amount of organism can be found in the marine organisms can be found. And what happened around 200 to 300 million years ago, large amount of marine organism lies in the deeper ocean. Marine organisms are very less, and maximum marine organisms are in the continental shelf. So these 200 to 300 million years ago, this marine organism has been died and died, and they have been deposited below the sediments brought by the what river glacier. So this is in a kind of sediment, and below the sediment we can say that there is a what marine animals, buried marine animals. And these marine animals, we can say like these marine animals, what is happening to the marine animals, they are started decomposing and converted into decomposition start decomposition, and it is how many years? 200 to 300 million years, and it has been converted into crude oil. And I said that different natural gases, so many things, everything is forming in this continental shelf. So I have given some idea about the continental shelf also. And another one, when ocean and when ocean continental convergence is taking place. So ocean continental convergence is taking place. This is in a continent. It is moving over here. It is an oceanic plate, and denser oceanic plate, what it goes down, and here water is there. So the deepest part of the ocean, this is what I say, the deepest part of the ocean, the trench is there. So trench, oceanic trench, if you can say that, oceanic trench. So it is the deepest part of the ocean below more than 6,000 meter, because till 6,000 meter it is an abyssal plain. Below 6,000 meter you can say that oceanic trench exists, and it is in a kind of V shape and all. So along the subduction, ocean continental, and you can be able to say along the ocean continental, as well as you can say that when the one oceanic plate is there, one is oceanic plate and another is also oceanic plate. So more denser oceanic plate is what this is an oceanic, and this is also oceanic. Both are coming towards each other, and here it is also coming towards each other, and above you can say there is a water is there. So between ocean convergence, here it is an ocean and ocean convergence, you can also say that the same way there is a trench is existing. And what is oceanic trench? So here we are going to see it is about what some trenches and all. So here let us see about continental shelf, abyssal plain, oceanic trench. Thereafter I'll come to this topic, and here we are going to see here, you can say that this is your continental shelf. Here this is in a continental slope, there is some continental rise and abyssal plain, and the same way here continental shelf is there, and the 200 meter depth there is a continental slope is there, continental rise it is there, and thereafter abyssal plain. And this is what you can say that trench is existing, and here you can say abyssal plain. And what is happening, the continental shelf, meaning continental shelf is the what gentle sloping. Yes, you have seen very flat kind of a gentle sloping, shallow part of the ocean. What is the meaning? 200 meter depths it is, okay, and it is an extending from the coastline to the what shelf break, where the shelf break is taking place, means after that continental slope start, till that it is in a continental shelf. Key features, width varies, and you can say that in the Siberia region the continental shelf is the large. Continental shelf is large in the what Siberian region, but where that two plates are subducting, in this one it is in a narrow. It is a continental shelf is a narrow in the region where the like South America Andes mountain ocean continental convergence, like in the Rockies mountain, Juan de Fuca plate and North American plate ocean continental. In this one it is a narrow because of the what bending on plate. So but in the Siberian region you can say that around 1500 kilometer long, and in the what nearby South America, child country and all, very narrow. The country having large continental shelf, they can have what good amount of petroleum reserve, different kind of natural gas reserve. So here you can say that width varies, very wide. Siberia wide, it is in a very wide, and in the child it is in a narrow, rich in what marine resources, fish, oil, natural gas, different things you can be found in the net in this region. It is formed by the sediments deposition from by the rivers. So rivers are coming, depositing, and then burying the what sediment, marine animals burying below, they are converting into oil and other things. Importance, major fishing grounds in this region. Major fishing ground in the shallow region, major fishing ground exist, that is in a Grand Bank, it is nearby the northeast of North America. And offshore oil gas extraction, yes, like in Mumbai High, this kind of it is there in the continental shelf. We are extracting what several what natural gases and what oil. And strategic for coastal economies and security, it is in a very much important for coastal economies, and you can say that it is in a this kind of at 200-meter depth there is a self break is existing. You can say there is a Abyssal Plain kind of it. Here it is in a what Oceanic Trench. So the question here, with reference to the continental shelf, consider the following statements. It is the shallowest part of the ocean floor adjoining the landmass. Yes, you have to find out whether it is right or wrong. It has a steep slope, ends abruptly at a greater ocean depth. You have to find out whether it is right or wrong. It is a rich in marine resources such as fish and hydrocarbons. Okay, so we have to answer this question, and we will discuss about it in the sixth episode. We will discuss about it in the sixth episode for this 100 most important topics for Prelims 2026 of the geography. So in the sixth episode, it is the fifth episode it is going on. It is next part we are going to see, it is about Abyssal Plain. It is known as also deep sea plain. And the deep sea plain we have discussed already. Abyssal plains are extremely flat deep sea plains found at the depth of 3000 to 6000 meter, and among the flattest region on the earth. It is completely flat and covered with the very fine sediments, clay and silt. Remember that, because anything is very fine, they can go on the down, and there is a reposition making flat clay and silt. Remember, located between continental margins, means where the continent is finishing that continental rise, and mid-oceanic ridges. So it lies between continental part and then mid-oceanic ridge. And formation formed by deposition of sediments over the irregular oceanic crust. So ocean crust regularly there is what deposition by the meteors, different thing. It is deposition making it flat. Importance, store vast geological records. Lots of records out there. You can be able to say yes, fossil evidences are there. Potential for deep sea mineral resources like polymetallic nodules, cobalt, iron, manganese, phosphoric. These are the different kind of what in the minerals can be found. Here it is an oceanic trenches that you can say. So consider the following statement regarding abyssal plain. So they are covered with fine sediment like clay and silt. Yes. Second statement, they are found near mid-oceanic ridges only. And then mid-oceanic ridges only, they may contain polymetallic nodules. So you have to answer it, which one is correct or wrong. And now that oceanic trenches, that we have to see oceanic trench, it is our long, narrow, that you can say that is in a long, it is there or not? Long it is there. And what I said, that narrow, it is narrow, and a very deep depression. So it is in a V-shaped, very deep depression, long, narrow, and very deep depression in the ocean floor. And key feature, depth exceeds 6000 meter, and where it is forming associated with the subduction zone, means ocean continental subduction, and along with the ocean. and steep sided and V-shaped profile. It has a which kind of V-shaped profile, and you know that nearby Philippines there is a Mariana Trench. This thing we have done in the earlier episode when I was doing plate tectonics. We are doing divergent, convergence, Himalayan. This earlier episode I have completed that how do the ocean trenches there. So please go, and if you have a doubt in that one, or perhaps if you have not seen that video, so please go back, see all the episode. Is very much important for your what I said the preparation for your prelims 2026. And Mariana Trench is the long, it is an what deepest trench. It is around 11,033 meter, or some books is talking about 11,034 meter also. Tonga Trench nearby New Zealand and the Java Trench nearby Indonesia. These are the important trenches are there. So with reference to the Oceanic Trench, consider the following statement. So they represent the shallowest part of the ocean floor. That is talking about ocean. It is in the shallowest. Yes, you have to say whether it is right or wrong. Another, they are associated with the subduction zone. Yes, it is associated with the subduction zone. We have to see whether it is right or wrong. And they are often sites of intense seismic activity. Yes, you have to see whether it is there or not. So these are the things we have to see whether it is right or wrong. So please give your answer accordingly. And we have to see that next topic. It is about Atlantic Meridional, yes, overturning circulation. You know that if I am talking about Atlantic Meridional overturning circulation, means meridian, longitude is known as a meridian. So along the meridian there is some kind of overturning circulation is going on. And what kind of circulation we can be able to say? So in the equatorial region, if I say that it is an equator, from here you can say warm water is going on, towards the polar region, and the polar region has what I say that there is an colder temperature is very low. There is a cold water is there, and this cold water in the polar region, in the high latitude region, they become heavy enough, start descending, and then they are start moving towards what I said that this region. So this is happening, and it is again coming back. So this circulation is going on, and it is this is known as I said Atlantic Meridional overturning circulation along the meridian. Let us see why and how it is happening. So these things overturning. So mechanism, how it is happening, let us see how it is happening. I have told you warm surface flow, warm saline water moves northward via currents like the Gulf Stream. So along the eastern part of North America, Gulf Stream, warm ocean current is going on, and cooling and increased in density in high latitude in the polar region nearby that. In high latitude, there is water cools and becomes denser. Means anything is cooling, it is become pressed and become denser and start moving down. So sinking and downwelling, we can say the dense water sinks in the regions like North Atlantic and deep ocean flow. And when it is coming down, that from there it is from the pole region started coming. It is in the polar region, high latitude, heavy, started moving down, and then started coming towards equator in the down. So the cold deep water flows southward towards the southern ocean side. That cold deep water flows southward toward the southern ocean and upwelling. And now when it is coming able to, then water naturally rises again, completing this cycle. So one cycle is completing, it is known as an Atlantic Meridional overturning circulation. This is also known as a thermohaline circulation. Thermohaline means temperature and salinity. You know that if the water temperature is less, colder, it will become heavy and it started going down. If the salinity of the ocean is higher, that is also a denser water, and the denser water started also going down. So thermohaline, that somewhere salinity and the temperature plays for the what I said that the circulation of the air. If there is a warm water and there is a cold water, more saline water, less saline water. This is the important for. So this is what we can say that Atlantic Meridional overturning circulation. So what is the important? It regulates global climate. Yes, sir. If it is going to disturb, if it has been disturbed somewhere where the warm ocean current is there, there can be a cold ocean current relatively, and where there is a warm ocean, cold ocean current, there can be a warmer. So slowly and slowly in the Atlantic Ocean, again let me tell you that ocean current speed is decreasing. Therefore, I am teaching you this one. So it is decreasing. So the climate can be changed. So where the cold water is there, the warm water started coming, and that leads to atmospheric circulation to change. Hadley cell, Ferrel cell, polar cell, all this will change, and that finally it will be in a great change. Climate change can occur, great change. So global climate, this atmosphere, it is in a what Atlantic meridional overturning circulation, maintaining the global climate. It should not disturb, and keeps Europe warmer than expected. You know that keeps Europe warmer than expected. Yes, and influence monsoon system, because monsoon also depend upon the warm sea surface and then cold sea surface. Somewhere it will affect monsoon. Go and study about that, the monsoon mechanism. And controls carbon and heat distribution. Yes, heat distribution is there, and you know that carbon means in the warm, in the cold water more organism, and this organism means phytoplankton absorbs more photosynthesis, and then more carbon dioxide, more photosynthesis, more nutrient in the cold water. So therefore more carbon sinking, but in warm water less carbon sinking. So you can say that if it is an AMOC, means Atlantic Meridional Overturning Circulation is going there, so it is affecting, it is in a controlling the carbon as well as what I said, that heat distribution in the world. Organism, carbon means organism distribution. So here we have seen, and here the cold water goes down, here they can say that cold water comes down, and then warm waters, it is moving up, sinking in the north, cold water southward, it is going down, upwelling, and these are the things which is happening. So with reference to the Atlantic Meridional Overturning Circulation, consider the following statement. It involves northward movement of warm surface water, and southward flow of cold deep water. You have to see whether it is right or wrong. Another, it is driven primarily by the difference in temperature and salinity of the ocean. I have talked about thermohaline. So where is the warm, where is the cold, where is, I said that more salinity and all. So thermohaline solution, I have said. Therm means heat, haline means salt. So it is driven by primarily by difference in the temperature and salinity of ocean water. You have to see whether it is right or wrong. Another, it operates only in the Pacific Ocean. You have to think about it. Already it is Atlantic written, and here it is operates in the Pacific Ocean. So we have to see this question. Now that we have to see the climate impact of warm ocean current. Suppose I am in the coastal area and warm ocean current is going on. If the warm ocean current is going on, so the coastal area will become warmer. Yes or not? Warmer, coastal area will become warmer, and at the same time, because of the more moisture, some rainfall will also take place in the coastal area, and some vegetational growth will take place. So I said that in the vegetational growth, forest, it will be there. So we can say that like in the, if we can be able to say like in the warm ocean current, Gulf Stream and Kuroshio, I said that coastal area will be what you can say that coastal area will be what warmer. So there will be a warm, you can say that in this region, warmer climate will be there. Yes, rainfall will happen, more humidity, and winter will be not very cold because of the warm ocean current. Coastal area, what do you think if it's a warm? So winter will be less. Yes, and a cool kind of it, mild winters will be there, mild winters, and you can say support marine biodiversity. But marine biodiversity, lots of fishes will be there, but relative to the cold, it will be less. Is it okay? So we have been able to say that this one, Gulf Stream and Kuroshio, it is in North America side. It is in what Japan, you can say it is flowing toward the what Japan side. So climate impact of warm ocean current. Warm currents carry heat from the equatorial region to the higher latitude. We have seen, and here, and then important name of the ocean current we have seen, Gulf Stream, yes, and Kuroshio current. Warmer coastal climate, it will be there. Climatic effects, increased rainfall and humidity. Winter will be milder, and what you can say that like in the Western Europe it is going on. And then support marine biodiversity. So these are the things we have seen. So that question based on it, with reference to the warm ocean current, consider the following statements. Warm currents generally increase temperature and humidity of adjacent coastal area. You have to say that whether it is wrong or right. Second, warm currents are often associated with the arid coastal climate. Arid means desert kind of it. We have to say whether it is arid or not. Warm currents reduces marine productivity by limiting nutrient availability related to the cold current. Okay, so these are the questions you have to see and answer accordingly. Is it clear? So that next part that we are going to see, it is a climate impact of cold ocean current, and there is a cooling will be there, colder region, desert formation. Yes, due to the cold water there can be a fog formation, cold water. And if you have seen that during the winter fog forms, some moisture comes, suddenly they convert into RH 100% saturated, and then fog form along the water, cold in the region, fog formation can take place. And yes, you can say like climatic impact of this one. You can say that Labrador cold country current you have seen, fog formation can be there. Yes, rich fishing grounds can be there. Yes, rich fishing ground can be in this region. So we have been able to say that desert and all. So here that climate impact of cold ocean current. Cold currents flow from polar, means high latitude, to the equatorial region that you have seen. Yes, here you have seen that and it is in a cold currents flow from polar to equatorial region, like Labrador we have seen. The several currents are there, Labrador cold Canary current, Oyashi current. Yes, there is several such, California cold current is there, Benguela cold current is there, several names of the cold ocean currents are there. So here what is the impact of it? So cooling of coastal region will be there, dry condition will be there, because in the cold air less moisture means dry condition. Formation of deserts in the coastal area like Atacama Desert due to the cold Peru current. In the Atacama Desert in the South America, nearby Chile and Peru, and there will be a fog formation, meeting of warm and cold ocean, means cold water is there, and then warm water comes, moisture, and then moisture will convert into fog. RH 100% rich fishing ground due to the upwelling of nutrients, because the cold water upwell, more nutrients, rich fishing grounds can be there. So on the basis of that, consider the following statement regarding the cold ocean current. The Labrador current is a cold current flowing southward. You have to talk about whether it is southward what. The meeting of warm and cold currents lead to the fog formation and rich fishing ground. You have to say whether it is right or wrong. Cold currents are generally associated with the nutrient-rich upwelling zones. So you have to answer these questions, and I'll be waiting for these questions, your comments, answer for all these questions, and your comment will be valuable for us and for me especially. And in the what we can say that in the next class I say that in the 6th episode the more other topics will take, but at the same time in the 6th episode I will explain about all the questions that I have given in this 5th episode. So we'll meet in the next episode, 6th episode. Till then,
for more informative content, like, share and subscribe. And do not forget to press the bell icon to get the notifications.